What is going on, everybody? It's Conley here with the Science Knights, and two knights are assembled today. Dr. Anirban Bhattacharjee is hard at work in the field right now and can't join us, but you know what? We have Dr. Thomas Shiller and Dr. Sean Graham here.
Hello.
And, whoa, hey, they have something very interesting to talk about today. Tetrapods. Have you ever wondered what a tetrapod is? I mean, I have
something
a little fossil.
I think about every day. Yeah.
It is. Okay, well, of course, right? But no, I have a little fossil. Okay. Fossils here and there of little tetrapods. I believe they're tetrapods. Maybe they're not. Maybe you can tell me more about them. What is a tetrapod? How do you identify them?
Well,
you are a tetrapod.
Yeah, you're a tetrapod. I'm a tetrapod. A lot of things are tetrapods.
Everybody listening to this show right now is a tetrapod.
So I had more legs than I have right now.
I think
how many you got? How many you got? How many is?
It depends on who you're asking.
How many is tetra? The tetra here. We'll do a count. Tetra means 4. How many limbs do you have?
4.
All right, you're a tetrapod.
Why was there a pause there?
It's double checking.
I was doing the math.
Yeah. So tetra, of course, means 4. Kind of the basic definition is 4 limbs, but we'll get to that, or 4 feet, I should say.
Mm-hmm. And what this show is really about is about one of the most important transitions in the fossil record, one of the most important transitions in vertebrate history.
Yeah. If it weren't for tetrapod evolution, we would not be here because we're tetrapods. So, the story kind of begins, typically when I have a show related to paleontology, it's all about the story. So we have to go back a little bit further in geologic time to talk about the beginnings. Tetrapods originated from fishes, okay, which means we originated from fishes.
That means that not only are you a tetrapod, you're also a fish.
And I have gills.
You do.
Yeah, in your early embryological stages, you do.
That's the most...
we'll save that for our next episode, though.
No, we can talk about it now, because I think we'll just, in brief, there's several features of vertebrates that all vertebrates have, and you show them, but just not as an adult. But you say gills, and that's awesome. I'm glad you said that, because when you are like 2 weeks old, you look like a little bitty fish. You look like a tadpole, and you have gills. And those gills eventually turn into your jaws. And that's a clue as to where jaws came from.
Yeah.
But yeah, jawed fishes would be a good topic for a whole episode. But we're going to move past that. But this is kind of where we're talking about. We're beginning with really early stuff, and we're talking about the evolution of fishes. And so, where do you want to start?
So let's start in the Devonian. That's a good place to start. So
let me get my snorkel and my mask.
Yeah, you'll need a snorkel and a mask to talk about the Devonian, because nothing really other than plants and arthropods and some other organisms are living on land. But the oceans are filled with fishes at the time. Now, when we talk about vertebrate paleontology, when we talk about animals that have backbones, we spend a lot of time talking about fish, because fish came about really early on in the evolution of animals. Very, very close to the origin of multicellular organisms, basically. So when you talk about fishes, you see this kind of long, complex lineage, but at least where fishes pertain to the evolution of tetrapods, and ultimately the evolution of us, you have to look at the Devonian. Now, the Devonian is kind of the time of the fishes in the Paleozoic, because we see this huge radiation event of different groups of fish. Okay, when we talk about radiation, we're basically talking about the emergence of species over a short period of time.
Yeah, not radioactivity.
No,
radiation is like a evolutionary term for multiple origins of lots of groups.
Oh, so you're talking about radiation in the biological world?
Yeah, in the biological sense.
Right, not in the physical, physics.
Not radioactivity.
Right.
Yeah, there wasn't some sort of mutation or a radiation event that caused...
No Chernobyl.
No Spider-Man fishes.
Okay, all right.
No, so good we got to establish that. Not that many people are that familiar with that term, like adaptive radiation, but this is an evolutionary term of like multiple groups exploding all at the same time from like one kind of early starting point. So ton of diversity of fishes happening in the Devonian.
Yeah, so if we look back at the Paleozoic, we have all these groups of fishes. We have these really bizarre armored fishes earlier on. We have early sharks, the chondrichthyans, and other cartilaginous fishes. But what's important to the evolution of tetrapods is the emergence of two major groups, two groups that exist today, the lobe-finned fishes and the ray-finned fishes.
What are some examples? Where would you find those fishes?
So ray-finned
for the fishermen out there.
Yeah, if you're a fisherman, if you've caught a fish, you've probably caught a ray-finned fish.
So they're the fishes everywhere in the ocean, freshwater. So catfish, bass, cichlids, tetras, everything.
I don't know. Those catfish are just like swimming foreheads out there. They're like giant little foreheads, just like swerving towards you. But,
but
even them, they're ray fins. It all comes down to what supports the fins, the two paired fins on either side. And with the ray fin fish, there are these kind of proteinaceous rays, these rods that kind of support the fin. And then the lobe fins. What's a lobe fin got in its fin?
So lobe fins are quite a bit different, at least when you look at their fin structure. They have more robust bones that support their fins.
Bones and muscle.
Yeah, bones, and they're really muscular fins. So if you've ever seen, like the two modern examples we have today are the coelacanths and the lungfishes.
And nobody knows what a coelacanth is, but the lungfish, some people have probably heard of that. And the modern lungfish is weird. Some of them, we've got them in our fish tank at the school, and it's really cool. They've got these weird kind of tentacles for fins, really heavily modified. But in the Devonian, there were tons of lungfishes, right? And tons of other lobe-finned fish. The diversity was actually almost equal between the lobe fins and the ray fins.
Yeah.
They were actually kind of, competing at about equal footing. There's about as many of each. Nowadays, though, there's only a handful of lobe fins that we call fishes left. Now, that's a crucial thing. There's only a few lobe fins that we call fishes left. Turns out there's a lot of lobe fins left. In fact, about as much diversity lobe fins as there are ray fins in the ocean. They're just all on land now. And we call them people. And we call them weasels. And we call them, we called them dinosaurs, right? So one of the lobe fins gave rise to the tetrapods. Yeah. That's what we're talking about today. Isn't that exciting?
So they willed their way out.
It's not.
Yeah, there are a lot of things
where there's a will, there's a way, I guess.
Yeah.
Something like that.
You could say that.
Yeah. So the emergence of these two groups, especially the emergence of the lobe-finned fishes, the Sarcopterygians, really kind of facilitated this gradual movement onto land. Now, to kind of set the stage as to what's going on in the Devonian and later into the Carboniferous, when the tetrapods really kind of took to the land, you had all this competition going on in the oceans. Okay, when radiation occurs, as Dr. Graham was talking about, you have all these groups that emerge that they're competing. They're competing for resources. So when plants moved on to land, and we have all these insects, these arthropods that are on land, you basically have this open, available niche or niches on land for some creature to occupy. So the contest was between the ray-finned fishes and the lobe-finned fishes on who would somehow figure out how to get onto land. Now, when I say figure out, keep in mind that this is a process that took place over millions of years. This wasn't like, a light bulb went off in a lobe-finned fish's head, and he said, "I'm gonna."
That's a huge misconception. I think a lot of people have that misconception. They see in the textbook, they see these little evolutionary trees that we love to put in textbooks, and it shows like a jawless fish, like a lamprey, and then it shows a shark, and then it shows a largemouth bass to represent the fish, and the next thing on the tree is a frog. And so the students look at that and go, "Oh, this moron expects me to believe that a largemouth bass laid an egg and it became a frog." And nobody expects you to believe that, but that misconception, I wouldn't believe that either, right? What we're talking about is much slower, and all the things that, a frog is actually a pretty advanced amphibian. It's very advanced. There were a lot of intermediary steps between the earliest tetrapods wouldn't have looked much like an amphibian, like a modern amphibian. They would have been probably slimy, but they were big and clunky. You wouldn't have liked them. They didn't look like cute little frogs. And so there's a lot of steps between, and it wasn't even a largemouth bass, right? It was something with lobe fins, and nobody knows what those look like, right? Because if I showed you a lungfish, you go, oh, that actually does look a little bit like a salamander.
Yeah.
It looks a lot like one. The first time I saw a lungfish, I didn't know what I was looking at. I couldn't tell.
Really?
I was like, what?
They're alien looking.
Is
They
that a
have
salamander?
the real big, like...
They have these long, spindly pectoral fins that are really bizarre.
The African lungfish, the Australian lungfish.
Similar to the gills of a salamander?
Well, they do. They have external gills.
Yeah.
And at least the African lungfish does.
Yeah.
And then the Australian lungfish, it's got much more like limb-like fins that are real muscular, and they can kind of prop themselves up with them. So they look more like probably what the original tetrapod limb would have looked like than a modern African lungfish. But anyway, if there's a lot of fossils, and we kind of know what they would have looked like, and there's a lot of evolution between these lobe-finned fish and modern amphibians.
Yeah.
And so it's not a largemouth bass and then a frog.
So it's safe to say that an apple didn't fall on a fish's head and then boom,
Right.
discovered gravity.
Right. Yeah,
No?
it would have been a
Didn't
gradual,
happen, right?
gradual process where every little tiny change, right, incremental tiny change would have granted it an advantage. And that we're going to talk about like some of the scenarios of how these, you could go through very slow stages, very, very incremental stages to where finally you're completely on the land.
Yeah.
Thanks to natural selection.
Thanks to natural selection.
Yeah.
So let's go back to the structure of the fins of these two groups of fishes, because Dr. Graham did a really good job of describing the differences. We have the ray fin fishes, which if you've ever caught a largemouth bass or catfish or anything, pretty much you can see that their fins are made up of these really thin rays, or radials as they're called. But if you look at the structure of a lobe-finned fish, again, we have modern lobe-finned fishes that we can look at, and fossil lobe-finned fishes. They have these larger, more robust bones. Now, what this allows for is not getting up and walking on land like the textbook might portray, but at least back in the Devonian, what that allowed for was movement into maybe shallow waters and maybe periodic movement onto land. So a really gradual kind of advancement in evolution. Now, kind of going back to the textbook example that's given, this is a really big issue when it comes to detractors of evolution. You've probably experienced this too, Sean.
Oh, yeah.
Historically, at least until the early 2000s, the transition that we're talking about here between the lobe-finned fishes and tetrapods was not completely understood. So we've talked in previous episodes about how incomplete the fossil record is, and how we're kind of missing some gaps or some links in the chain. The common bromide is the missing link.
Yes, missing link.
The missing link. So for a long time, we had a missing link when it came to the transition from lobe-finned fishes to tetrapods, to these four-limbed animals that moved about on land. Now, what happened in the early 2000s, a scientist or a group of scientists spent 3 years, 3 field seasons up in northern Canada above the Arctic Circle.
Is it Ellesmere Island, right?
Yeah, Ellesmere Island.
This is a place where they practice Mars rovers. It's a place so awful and formidable that NASA will take Mars rovers up there and run them through the ringer, because this is places where polar bears are. Mm. They would take guns up there to fight off polar bears if they had to. This is crazy. Yeah. They got choppered in and dropped there for the whole summer, which is like 3 months or something there.
Yeah. So
great story.
Paleontologists will go to great extents.
Think of the links they're going to. I use this story all the time, especially because I know I've got a ton of like creationists in my classes, and I go, look, this is what we're going through to provide the evidence that you are claiming that you need, right? They do say that. They'll say, you don't have a missing link to prove it. Mm. In fact, there's a creation scientist, I use his quote in the first slide of this lecture when I talk about this. He says, if this really happened, then there should be fossils that show a 10% fish 90% amphibian, a 50-50 fish amphibian, and a 10% amphibian, 90% fish. There should be fossils that show that. And then when we show them that, they go, well, what about the 25-75, right? So it's like there's just no amount of evidence. But this one's a big one because the links that they went through to find this.
Yeah, basically before the early 2000s when this discovery was made, we had all of those other links.
Right, we had like 10%, 90%, and on either side.
We didn't have the 50-50.
Yeah, we didn't have this, and we're going to tell you about the 50-50. And it's such a cool 50-50. It's perfect.
Yeah, so... the story, as I've heard it, is the scientist Neil Shubin is his name.
Yeah, Neil Shubin's a good buddy of mine. He's going to be on the show next week, guys. I'm only kidding. It would be kind of a big catch for us.
He's a paleo rock star.
If you're listening,
just
Neil,
give me a cell phone, credit card information, zip code.
I think we have to give him our credit card information.
We'll give you our bank routing number if you come on our show, Neil.
Yeah. So Neil Shubin puts together this expedition. The kind of story that goes behind that was he was in his office with a colleague of his, and they were talking about potential places to go prospect. We've talked about the process of finding bones and all that in previous episodes. But to find these great discoveries, you first have to go out and you have to look for them. You have to prospect. So they were kind of laboring over all these maps and notes and stuff, trying to figure out where folks had not visited.
So they got to find like shallow water terrestrial deposits from the right time period that no one's ever been to before.
Yeah.
And what do they come up with? Mars, basically.
Yeah.
Mars on Earth.
Yeah. So northern Canada, basically. And they found it in an old textbook. I don't know if you know that part of the story.
I didn't know that. That's
yeah,
pretty
they
great.
had this pile of literature on Neil Shubin's desk. And Neil Shubin had a textbook from when he was a graduate student. And he opens it up to page 50, and there's a map showing all the Devonian exposures around the world. And they started checking off where everyone had visited.
Yeah.
And here's this little tiny blob up in the most inhospitable place in North America. And they say, we need to go there.
That's where we need to go.
And they went there.
3 years, they find nothing.
Yeah, they found a lot of cool stuff.
Oh, right, that's right.
They found a lot of cool lobe-finned fishes.
Yeah.
They found the fishes that kind of lead up to the big 50-50 transition.
Yeah, stuff that people have already seen before.
Yeah, but they didn't find the fish.
Right.
But the third year, I think it was close to the very end of their expedition, one of the team members.
It was an undergraduate.
It was an undergrad. Yeah, I think he got lost.
That's right.
He got lost.
They were about to, he's like he's out
undergraduate
past their kind of curfew, and they're like, oh God, we got to go look for him, and then he comes stumbling in, right?
Yeah. I can. This is funny. We can relate to this, Sean, because I can think of how anxious these guys must have been with an undergrad who wandered off. But, it turned out to be a good thing because. He came running into camp, and he said, "I found something cool."
Yeah.
He's
since gone to become a PhD.
I think so. I can't remember his name, but I think he's become an expert in tetrapods. I want to say,
I can
but
imagine.
I can't remember his. Geez, but he finds something really cool, and. I'm gonna leave some suspense here. When we come back from the break, we'll talk about what he found.
To you what this thing is.
Because this is one of the.
Should we go ahead and tell them the name before we go to the break?
Okay, keep this on your mind. Tiktaalik.
Tiktaalik.
Tiktaalik
is the beast.
The famous Tiktaalik. Why
right.
don't you look it up? It's spelled Tiktaalik. That's how you spell it.
There's two A's in there.
It's an Inuit word, and I'm sure you guys all know what it means.
Yeah.
Terrifying.
We'll describe it when we come back, everybody.
Yeah, we're going to come back after the break. Keep it right here.
All right, welcome back. We are the Science Knights. Today we are talking about tetrapods. If any of these subjects interest you, or if you have any sort of sciencey question, feel free to give us a call. We have a hotline where you can call in and leave a recording of a question you have for the Knights. The number is 432-217-1983. Again, that is 432-217-1983. Also, visit our Patreon page. Look up Science Nights in the Morning on Patreon. If you enjoy our content and would like to contribute, please do so. We have several tiers that you can donate to, and some of those have some really cool swag, some T-shirts and coffee mugs and cool stuff.
I want to support us so I can get those flip flops.
Yeah, I want the Science Night
flip flops. Look
great. Okay, so back to what we were talking about before the break. We were discussing tetrapods, and I kind of left everyone hanging with this suspenseful story about the discovery of a really important vertebrate fossil called Tiktaalik. Now, where we left off, Neil Shubin and his team had been up in northern Canada. This was their third year being up there and basically not finding anything too important. But close to the end of their expedition, an undergraduate student wandered off and he found something that turned out to be incredibly important. So the undergrad comes running into camp that evening and says, "Hey, I found something cool. We need to check it out." And the next day they go and they check it out. And what it ends up being is this new genus of vertebrate animal called Tiktaalik. Now, in paleontology, and we've talked about this before on the show, we talk about missing links or transitional fossils, where we actually see the true transition between the primitive or the less derived forms of a group and the subsequent derived forms. Okay, basically seeing evolution take place in the fossil record. Tiktaalik is the missing piece to what was a pretty darn complete puzzle when it comes to the evolution from fish to four-limbed animals that walk around on land.
Maybe we should set up what we already had before Tiktaalik, because we have the early the early lobe-finned fish like Eusthenopteron. Is this kind of torpedo-shaped fish that would have looked like a fish to you. But it did have in the lobe fins. It had a really big bone, in all four of the fins. It basically corresponds to the humerus and femur of modern tetrapods. So all modern tetrapods have a single element that's kind of stuck into the body, right? And then there's
connecting to their shoulder,
right, to the shoulder,
or their hip.
So your forearm, your arm bone, the humerus, and the femur, and then you have these paired elements towards the end, right? The radius and ulna, and the tibia and fibula. All tetrapods that didn't subsequently lose their legs, like snakes, have these same things, and then wrist bones, ankle bones, and then fingers, right? So we had we have plenty of lobe-finned fish with just the single base element. And then somebody in, where was it, Latvia or something like that, in the 80s, they find this thing Panderichthys, which is a fish that's got a radius and an ulna and a tibia and a fibula.
Yep.
It's got the paired elements that are out towards the end of the fin, right? And then a long time ago, they found up in Greenland, right?
Yep.
Canthus and Ichthyostega.
Yep.
And I'm going to let the paleontologist take over. What did those guys look like?
So, Canthostega and Ichthyostega have the upper arm. Well, Ichthyostega, I might have this reversed, but Ichthyostega had both of the forelimbs, the upper arm, the lower arm, and the hand, basically.
Wrist bones. And they've got fingers.
They've got digits. They have fingers.
But how many digits they got?
Ichthyostega had 8.
Yeah.
Picking them up.
Yeah. So, and Acanthus, they got too many digits, right? They don't have the base number for modern tetrapods is 5, which we, incredibly, humans still have that, right? Other mammals, they have less than 5. We kind of show the primitive characteristic. But these Greenland critters would have looked a lot like some sort of in fact, when they were found, it was like we found the missing link because they got too many fingers and they were aquatic. They still had tail fins.
Yeah.
So they looked like something in between. And the amazing thing about this sequence that we already had before Tiktaalik is that the time periods actually matched just right. Right, so the earliest ones were the ones that were older, the ones that showed just the base element, the humerus and the femur, and then the one with the radius and ulna, Panderichthys, was like 10 million years later. And then these other ones that look like something like more like a salamander with too many fingers, those were like 25 million years later. Yep. So the time period was perfect. So that's why Neil Shubin was like, I'm going to go right in between Panderichthys and Acanthostega and Ichthyostega and see what I can find right there. So it was one of these great examples of how science can rely on predictions. He went specifically to this window of time where it should have been 50-50. Because everything we talked about so far, like Panderichthys was something like 25% amphibian, 75% fish. And Ichthyostega, Acanthostega were like 90% amphibian and 10% fish. So we're still looking for 50-50.
Yeah, we're looking for the 50-50.
And this is my favorite part because now that we've set it up, you can tell us what Tiktaalik looked like.
Yeah. So to continue with the story, they went out to this spot that the undergrad found. And exposed at the surface was the lower part of the lower jaw of a lobe-finned fish. And Shubin and others were able to say, well, this is obviously a fish. But they started digging. They started digging back in the hill, which is really the most thrilling part of paleontology.
Oh, right.
And you've gotten to experience this with me.
You never know what's going to be there.
It's a treasure chest, basically. Yeah. And in this case, it was truly a treasure because they dig back. And shortly thereafter, after they uncover the skull, they get to the forelimbs. And what they find is what they were looking for. They were looking for this missing link in the chain where you had the single upper arm bone.
It's got a humerus, it's got a radius and an ulna.
Radius and ulna. It has some weird wrist bones.
And it's got wrist bones.
And it has, well, the digits weren't quite there.
It doesn't have fingers.
Yeah, the
it
fingers
doesn't have
weren't quite
fingers.
there.
So it's got it's the first tetrapod with wrist bones, but there's, instead of fingers, so lobe-finned fish actually have ray-like elements too. It's just the base of the fin is this muscular bony structure. So this, in life, it would have had wrist bones and a kind of like a ray element at the end, like it was somewhere between an arm and a fin. It's 50-50.
Yeah.
And I love how you're talking about, like, they find the face and they're like, okay, this is a lobe-finned fish. As they're looking at it, they're like, it's a fish, it's an amphibian. They don't know. Like, it's such a perfect, like, combination. It's stuck in the middle that they don't even know what to call it.
Yeah.
And it could have, the way that, once they start getting the rest of it out, they realize that it could have bent its wrist to kind of prop itself up.
Yeah.
But it didn't have fingers.
Yeah.
Not
Well,
yet.
they found... Subsequently, they found other specimens of it too. The first one they found didn't have the best pectoral girdle, the shoulder blade and all those elements. But they found other ones that had these big, robust pectoral girdle elements, which you don't see in fishes that are completely aquatic.
Yeah.
So
you need that to support the weight in gravity. You don't need that if you're a fish and you're not so this thing obviously would have been able to prop itself up.
Yep.
It had a distinct neck and could swivel its head around.
Yeah, its
no
head
modern
was
fish can do
separated
that.
from its shoulder, which...
My favorite part, though, this is my favorite part. They found the forepart of the animal, the head, the shoulders, and the forefins, and then they had to come back because after that they were like rock stars. This was enough, right, to get Nature paper, Science, the best, most prestigious journals in the world. They're published in those journals. So they get money to go back, and that's when they found the rear end of this animal, and that's the best part.
Yeah.
Because the rear end didn't have ankle bones. Even the fish itself was 50-50. Its back part was mostly fin, and its front part was more of a tetrapod. So even within the fish itself, which I can't, which should I call it, a fish? Should I call it a tetrapod? It's halfway between. It's
fishapod is the popular
It's exactly,
term.
and they never even predicted that. Nobody was like, oh, well, maybe the arms would develop more first. No one ever guessed that. They found it, they were like, oh, it's the fish itself is halfway between a fish and a tetrapod. It's unbelievable.
Meaning that it evolved enough to start exploring land.
Yeah, so it's got arms, and now we kind of, just from that little fact, we kind of have a better idea of how the transition would have happened. It would have happened first by propping up the forepart of the body and the head.
Yeah.
And then meanwhile, what's happening behind doesn't really matter so much. It's still got a tail fin. It's still got fins back on the back. The important thing is to be able to prop up the forepart of your body. Your shoulders.
I think it's important to mention too that these were found in like river deposits.
Right.
These weren't found in marine deposits in an ocean. They were found in freshwater river deposits. So this kind of sets the stage for, kind of the fun, creative part of what we do in paleontology, where we have to interpret both the anatomy of these animals, but also relate that to the environment that they're living in. And that's all geology. That's where the geology aspect comes into play. So when looking at Tiktaalik, as Sean was talking about, we know anatomically that this animal was capable, at least in some part, lifting itself up off of the ground, off of the substrate, potentially coming out of the water onto land, which is a really, really critical step. Because when we talk about evolutionary radiation, there are a number of things that can happen that kind of drive evolution. And one of those things is kind of opening up new resources. So when we look at tetrapods, or the early stages of tetrapod evolution, as I mentioned before, we have this huge open environment of land, of the terrestrial realm, where we have land plants, we have insects, we have things to eat. And we now have an animal that's capable of at least taking advantage of that in some part.
Yeah. And there's no other competition.
Yeah.
So in the ocean and freshwater, there's fish everywhere. But on land, the only thing there is insects and other things like that. So if you're going to, invertebrates are good at being big, right? They're way better at being big than insects. Insects can't get that big. So if you punch that lottery ticket and you're the first vertebrate on land and you can survive there, then you are going to just blow up.
Okay, well, where does oxygen make its role in this?
That's a good question, because they're still technically fishes, right? So they're still very much linked to the water. They have to go back to the water. They can't spend much time on land. So this brings up kind of two hypotheses as to what drove these lobe-finned fishes onto land. One, which is kind of the most popular one, or the most accepted, which we just covered, was that there were these open niches on land, and they kind of gradually moved and took advantage of that. But another one is that these animals moved into like shallow, low oxygen ponds. And that the lack of oxygen in the water, kind of what drove them to develop kind of more advanced lungs.
Keep in mind, they already had lungs. Yeah. They came from, lungfish is our closest ancestor that's still alive. We have every reason to believe that lungfish already had lungs and they could already breathe air. They've been able to do it ever since. And Tiktaalik probably already had lungs too. So there's an advantage of having lungs, even if you're not fully terrestrial. And lungfish show that.
Yeah.
So should I invite the next lungfish I see to my next family reunion? Like we're cousins?
Maybe for
like
like 10 or
related.
10 or 15 minutes.
Yeah. I mean, you're more related to like rats and things like that, but lungfish deserve a place in your heart. We should post a picture of, we got a couple lungfish in the lab, and we'll post pictures on Facebook and let you guys see what they look like. They're pretty cool. They're the coolest demo animals ever. They're really neat. But so those scenarios, I go over these with my students, and the scenarios for what would drive them onto land, there's a couple of, one of the earliest ones was that they were like lungfish, and lungfish live in these seasonally drying habitats. We call them, we have them in South Texas. In Africa, they're seasonally dry wetlands, and in Australia, they call them billabongs. And here in Texas, we call them resakas, if you guys are familiar with that. Like, what is the famous Mexican war battlefield, La Palma de la Saca or something like that. They're these seasonally dry wetlands. And what lungfish will do is they'll bury themselves in the mud and then cocoon down there and make a cocoon out of their skin, so that when the wet season comes again, it gets the pond wet, and then they emerge again and they're fine. And they can crawl over land to get to new water as well. And so the idea is that we have fossils of lungfish that are in cocoons from the Devonian, which shows that time period would have had seasonally drying wetlands too. But the problem with that hypothesis is that, that Tiktaalik would have been like a lungfish, is that he still wants to get to water, right? He's still trying to go from one pond. We need something that'll drive him out of the water forever, and that's where the insect thing comes in. It's like the exploitation of that resource and the new open niche. But I've got another hypothesis that I talk about in my class. There's other modern analogs to what I think Tiktaalik was, right? And what I call this idea is the edge hunter hypothesis. A couple of modern animals use the water's edge as their primary hunting and ambushing site. So alligators are a classic example, and the cottonmouth, a venomous snake of Texas. They hang out at the water's edge because the water's edge is an incredibly rich area where there's a ton of stuff coming. There's fish in the shallows, there's frogs going by, there's insects, birds come to drink, mammals come to drink. It's great. So if you set up shop at the water's edge, you're going to get a lot of resources. Yep. I think that could have been the kind of the missing link, right, between a fully aquatic fish-like animal and a fully terrestrial animal that could take advantage of all those insects. Would have been one that operated at the water's edge, and that's what I think Tiktaalik was. Because if you look at him, he's got this broad head. He looks like an alligator of some kind, and he could prop himself up in the water's edge with his eyeballs sticking up in the air. And I think that was what Tiktaalik was.
Yeah.
He also looks very friendly too. Like, I mean, if you pull up, just type in TIK
Taalik,
and that's an Inuit word for, like, I think it's something to do with fish. It's an Inuit word for fish, and it's like dawn fish or something like that. It's pretty cool.
Yeah, no, I'd definitely invite him to a gathering or.
If anybody wants to get me something for Christmas, get me a time machine so I can go back to the Devonian. I want to catch one of these alive so bad.
Yeah. And
it'd be so fun.
I bet they're delicious. I bet they. It's like
come on. Okay, let's.
I'm a fisherman. You listeners out there, you can
just
relate.
Don't get the one that's the ancestor of all of us.
Yeah, that would be a.
And that's
I guess I would just disappear.
It's another thing I think is cool about Tiktaalik, because once people found this, like a lot of times paleontologists will find something like this and what they call missing link. What Neil Shubin calls this is, he doesn't call it a missing link because that's a misnomer. He calls it a found link. It's found. Yeah. He found it. Yeah. Right. But a lot of times paleontologists will kind of dance around the idea of whether or not this actual fossil represents the ancestor, right? The exact animal that gave rise to the rest of the tetrapods. They'll say it's close to that animal. We think it's like that animal. But with this critter, people haven't really said that. They're like, this is probably it. It's so perfect that it's really unlikely we're going to find something more in that would have been more on the pathway of the evolution of the tetrapods.
At least it's a good representation of what that would have looked like. And the reason I say that is because, like anything in science, there is some debate.
Yeah,
like
you can always find something. You might find something better at some point.
Yeah, and you mentioned kind of the scenario of Tiktaalik and other similar animals being. What was the wording you used? They ambush predators?
Yeah, I think they're ambush edge hunters.
Edge hunters, yeah. And we have geologic and paleontological evidence of that, even in more derived groups like Ichthyostega and Canthus, what are truly tetrapods. We have both kind of physical or anatomical evidence of these animals kind of occupying that niche. But we also have trace fossils that suggest that. And one of the main points of evidence that supports the debate on whether or not Tiktaalik is truly the transitional species has to do with some trackways that were discovered in Poland that kind of predate Tiktaalik by, I think, like 10 million years. And these trackways show the remnants or the traces of an animal that had fingers, had digits, separated digits, preceding Tiktaalik by 10 million years. So basically saying that tetrapods may have evolved 10 million years before Tiktaalik was around.
Right.
Now, there are a couple of implications there. One of those is that Tiktaalik is truly the transitional species and just has lived for 10 or 15 million years.
A living fossil.
Yeah, the other one is that Tiktaalik isn't the true transitional species.
Right.
But this is something we face in science all the time, as new things are found that bring about some kind of debate. But we'll get back into that after the break. So let's go to a word from our sponsors at CDRI.
Hey everybody, we're back. Science Nights in the morning. We're going to continue talking about tetrapods, and now that we've left the water, we're going to see what happened afterwards on the land.
Okay, so last segment we talked about the kind of transition between fishes. Now we talked about the 50-50 fish kind of amphibian or tetrapod, Tiktaalik. So what happens after that? Well, as we mentioned kind of early on in the show, the transition isn't so rapid. So after Tiktaalik and similar animals evolved from fishes, basically what we see is there's still very much a link to the water. Okay, there's not this really drastic rapid jump from the water to land, but rather we have animals that show all of the physical characteristics that we would regard as being tetrapod characteristics. They have 4 limbs, they have fingers and toes, but their anatomy suggests that they probably still lived for the most part in water. We talked about some examples before of how we have trace fossils that show or give evidence to this kind of semi-terrestrial life mode, as we'd call it, where we see what are rocks that would have been deposited in aquatic environments with trackways of tetrapods. So fingers that are divided, definitely indicating that tetrapods are living there. So let's talk about some of the animals or the first or the earliest tetrapods that we find in the fossil record. We have a couple that we usually point to, like when Sean and I lecture to our students. We have an animal called Ichthyostega and a Canthostega. Now both of these animals are really fascinating and really bizarre because they still show some fish characteristics. They have tails that are kind of flat for swimming around, but they have limbs and fingers. They have digits. When you look at the structure of their skulls, they're still kind of fish-like. They still look like lobe-finned fishes.
Mouthful of teeth.
Mouthful of teeth, just like the fishes from which they evolved. So in the case of Ichthyostega and Canthostega, what we're seeing is the kind of last step or the last stage in evolution from what are truly fully aquatic fishes to more terrestrial animals. And we see this, as Sean brought up before, in kind of a sequence. We see the like Eusthenopteron, the lobe-finned fish, and then in between that and these early tetrapods we have Tiktaalik. And then we get into tetrapods that are probably living part of the time on land, part of the time in water. So following this stage, we get to the point where animals have figured out that living on land might be more beneficial, or it might be more advantageous than trying to compete with things on water in water. Now, we only have a few minutes here in the last segment, so we may save this part of the story for a later episode. But ultimately what happens is what leads to more advanced groups of tetrapods, animals that can move around on land, can breathe air, ultimately leading to amniotes, animals that can fully live on land. They can lay their eggs on land. They don't have any sort of connection to the water at all.
And our living amniotes today are, right, lizards, snakes, turtles, tuatara, which you guys don't know what that is. Don't worry about it. We got crocodilians, birds, and mammals. And they have this shelled egg, the amniotes. That's what amniotes are called that because they're named after this thing, the amniotic egg. It has these membranes and has a shell. And mammals have that too, but the modern mammals that you're familiar with, like you, ovulate that egg at a tiny size, and then there's a placenta and all that. But some of our earliest, mammals and our most primitive mammals, at least from the reproductive standpoint, still lay eggs, the platypus and the echidna. And the other main group that's still around, the non-amniotes, are modern amphibians. So frogs, salamanders, and caecilians, which are like worm-like amphibians.
Yeah, and the earliest tetrapods would have been not necessarily really similar to what we have living today. They were quite a bit different, but in terms of their life modes, they were quite a bit.
I think
similar.
they would have, the way they moved around and their lifestyle was probably like salamanders. Salamanders kind of show the most kind of primitive and ancestral features of any living tetrapod, but even modern salamanders are very different probably from the earliest tetrapods. But if you had to guess, a early tetrapod was probably like a big lumbering salamander that wasn't particularly agile.
Yeah. And as we've talked about previously or in previous episodes, when we have these evolutionary events happen, what I always tell my students is some weird stuff tends to happen. And it's no different when it comes to the evolution of tetrapods. In modern times we think of amphibians, we think of frogs and salamanders and stuff like that. But back when tetrapods first evolved, we had all of these really bizarre groups that emerged, like the Ichthyostega.
Well, is that the one with the huge necks that go? There's like some crazy early tetrapod that's got like a ludicrously long neck.
That's an early Archosaur.
Okay.
I can't remember the name of it, but the Ichthyostega, and you'll relate to this, Sean,
what are
because
these? I can't remember.
This is a early tetrapod, a very amphibian-like animal that lost its limbs.
Oh, okay.
It's like an amphibian snake.
There you go. Yeah, these kind of things happen more than once, right? You can lose your legs, and what I like is one of the earliest tetrapods is this thing, Crassigyrinus. It's basically, as soon as tetrapods got on land, they went right back and lost their legs and became fully aquatic again. And this shouldn't surprise us too much because, that's happened a bunch of times. Seals, marine mammals like whales, sea snakes, there's this kind of two-way street, the land interface. Once you're on land, you can easily go back. And there's examples of fish today that seem to be trying to get out on land, even though we've already done it.
Manatees.
Well, manatees are...
Well, they're not fish.
Yeah, they're mammals that have gone the other way. Yeah, that's
right.
That's another example.
So they want to get back to their fish friends.
So there's fishes that are trying to come out on land and show what the early evolution of tetrapods might have been like. So mudskippers are ray-finned fish that are... they're looking like they want to get on land, and really the only thing preventing, because they're really good, they can climb trees. I've seen them in northern Australia. I've seen one about 4 feet up in a mangrove, and they climb around. And the only thing stopping mudskippers from taking over the earth is the fact that there's already 20,000 tetrapods that beat them by 300 million years.
Yeah.
There's fish that use another ray-finned fish called frogfish that has very hand-like and foot-like fins, and he uses them for walking around on the bottom of the ocean. So even limbs could have been used for walking on the bottom of the ocean and then eventually help them to get out on land. They could have evolved limbs before they ever left the water. So the frogfish is incredible. You got to get a video of them walking along because it looks like it's just traipsing along, looks like it's walking on land, and they've got different they can gallop. They can get up speed and gallop across the bottom of the ocean. So there's a lot of examples of modern fish that show these tendencies that show that we really shouldn't have been, it's not that surprising that the tetrapods would have made it out onto land because it's happening all the time. And there's land animals going back into the water and aquatic animals coming back onto land. It's a two-way street.
It's really another incredible example of what we would call evolutionary convergence.
Yeah.
Or analogous structures, to be specific, because we've talked about this when we talked about birds and pterosaurs, flying reptiles. You wouldn't think that it would be easy, and it really isn't evolutionarily speaking to evolve powered flight. But several groups have done it throughout history in different ways, and we see the same thing happening with fishes and that are evolutionarily divided from the original group of fish that became tetrapods, became four-limbed animals that walk around on land. So whenever Sean or I see a video like this, to us this is spectacular. Someone might be scrolling through their Facebook and see this pop up and say, "Oh, that's kind of neat. This mudskipper's climbing up a mangrove root." But we see it and it's like, "Holy cow!"
Bingo,
this
bingo.
That's
Tiktaalik. That's Tiktaalik. And how it did it.
Yeah, and if you want to follow the Science Nights on Facebook, just all you got to do is just type in Science Nights in the morning on Facebook.
We're always posting news articles on there. It's a great source for your everyday science.
Yeah. And if you'd like to post something on our website that you find interesting, go ahead and do it. And we can comment on it, and we can share it ourselves, because, that's kind of the whole purpose behind what we're doing here, is to explain and to share science. The three of us don't know everything, so we're happy to see new science that emerges out there, and to share it with the world, and maybe talk about
everything, but we want to know everything.
Yeah, that's the thing.
Well, talking about just bringing it back home, right? Isn't our purpose to experience, explore, and inspire?
I think so. That's our stated goal somewhere,
right,
in the fine print.
And if you'd like to inspire us with one of your questions, please give us a call, 432-217-1983, 432-217-1983. Leave us a message, and you will be Alpine famous.
Well, world famous.
Famous. Yeah,
global reach.
Sure.
Globally famous. So another thing before we leave, I know we've mentioned our Patreon page here a couple of times, but the listeners out there should know that none of us really make a cent on what we're doing, and we've been doing this for almost a year now. And the radio station here in Alpine has been very generous in letting us record and broadcast episodes to you guys out there. And our producer has been very kind and generous in doing this all gratis. So we would very much like to make a little bit of money to help pay for those things. We don't really care about making a profit off this. We know we're not going to become millionaires. We don't care to do that. But if you enjoy listening to our shows and enjoy our content, please visit our Patreon page and sign up to one of our tiers. We do have some cool stuff that we can send to you if you do decide to support us. So check that out. And we thank you for listening. And we'll catch you next Saturday, bright and early, 10 a.m. on the Science Nights.